Okay guys, we're doing more problems on compound angle identities. So again, the compound angle identities is very important to understand the arrangement of the right hand side especially. So these two are formula 10 for level format, this is formula 11. So for 10 again, you see the arrangement is sine, cos, there's a mixture of sine and cos followed by sine and cos. Doesn't matter whether sine comes first or later. Then for formula 11, you see cos and cos followed by sine and sine. And for 10, if you see a positive on the left, there must be a positive on the right, negative on the left, negative on the right. For 11, it's a bit different. Positive goes with negative on the right, negative on the left goes with positive on the right. So let's now look at this problem. This problem is given to us and we are told to simplify. So this problem is not supposed to take you 5 minutes if you master your arrangement of the compound angle identities very well. A candidate who doesn't master it well might start expanding instead of simplifying. For example, if you start by saying I'm seeing from 11 year, 10 there, you see that you will be busy expanding. But somebody who masters that arrangement very well will see that at the denominator, this is cos and cos followed by sine and sine. So that is formula number 11. That's the arrangement for 11. The numerator is a mixture of sine and cos followed by sine and cos. So it means that is formula number 10 at the numerator. So your x here will be like your alpha here, then this will be like your beta. So if I'm to simplify, I'll be now writing the left side of formula 10, which says if there is a positive on the right, there must be a positive on the left. So if I'm going back to the left, I'll write my alpha first. My alpha is my x, my beta is plus 30 minus x. So you see, I'm simplifying, I'm not expanding. But if you want to do this one and do that one, you're busy expanding. Then here, this is formula 11 because there is sine, cos and cos followed by sine and sine. So that is obviously formula 11. So the left side I'll write in cos, and if I see a negative on the right, there must be a positive on the left. My alpha again is my x, then my beta is 45 minus x. So you see it's now looking simplified. Now inside the bracket, x will take care of x. The same thing at the denominator. So the numerator now will be sine 30. Then the denominator will be cos 45. So 30 and 45 are special angles. Sine 30 is 1 over 2 divided by cos 45, which is 2 over 2. And if I do my simplification by inverting, you will now see us, when I invert, what do I get? 1 over 2 times 2 over 2. Yeah, so it will give me 1 over root 2. That's my answer. So that's my simplification. But as I've said, if you are not very good with your arrangement of the compound angle identities, you might end up expanding these items instead of identifying formula 10 at the numerator and formula 11 at the denominator. Then it helps to reduce the problem to take you there. So thanks for that one. Let's now come back to another proof. So in this case, this is a multiplication sign. We are proving that cos x plus y multiplied by cos x minus y is cos square x minus sine square y. So with proofs, we all know that you choose one side, you work with it until you get the other one. And if you are a smart person, you will always choose the side that corresponds to formulas. So I'm going for left hand side, which is cos x plus y multiplying cos x minus y. So this is formula number 11 for math level 4. So if I'm expanding this is cos x, cos y. You know the arrangement for formula 11 is cos and cos, followed by sine and sine. The positive sign goes with a negative sign. So this is sine x, sine y. So that's the first ratio there. Then I multiply by the other one. So I have cos x, cos y, a negative sign will go with a positive sign on the right, sine x, sine y. So again, that's the next one. So at this stage, it's multiplication. So we need to start doing our multiplication of this one with that, multiply with that, multiply multiply with this, and multiply with this. And this is again where I like bringing in level 2 knowledge, because rather than wasting time doing this multiplication, a student who knows what is the difference between two squares will see that this is like a minus b into a plus b. So that formula in level 2 was saying if you get a minus b multiplying with a plus b, should just give us a squared minus b squared. That's what they call the difference between two squares. So it saves you a lot of time of trying to multiply out these things and wasting a lot of time. So what I will simply do is that if this is a minus b and this is a plus b, then my answer will just be a squared minus b squared. So I'll just concentrate here and take a and square it. So I'm squaring this, I'll be getting cos square x cos square y minus sine square x sine square y. So it takes care of all of that. And this is where I arrive, but comparing to my answer, I've not yet reached there. You see, I should have two terms, just like I've got two terms, but the first term should have cos square x only, the second term should have sine square y only. So I must figure out how do I take care of this, and how do I take care of this. This is where formula number 8 in our formula sheet, which we also did in level 3, steps in. So formula 8 says sine, since I want to take out cos square, I was saying sine square y plus cos square y is equal to 1. So I need something to replace this guy. So if I take this one this side, I'll be saying that cos square y is 1 minus sine square y. So in the place of cos square y, I'll be putting 1 minus sine square y. So if I come back here, this will be cos square x in bracket 1 minus sine square y minus, then when I compare this to where I'm going, you see, I need sine square to be there. I don't need cos square, sine square. I need sine square y, sorry, I don't need sine square x. So I have to take this one out. So to take this one out, I follow the same technique. So if I have sine square x plus cos square x equal to 1, since I don't need this one, I need to look for something that will replace it. So sine square x will be 1 minus cos square x. So in the place of sine square x, that's what I'll be using. So I'll be using 1 minus cos square x into sine square y. So I can now open up my bracket. If I open up my bracket, cos square will multiply there, cos square x times cos square x sine square y. And if I come here, don't forget there is a negative that is coming in together. So this will be negative sine square y, and this negative and this one will also come in together. Two negatives will become a positive cos square x sine square y. So at this stage you see that cos square x sine square y, cos square x sine square y, they appear with opposite signs. So this one take care of this one. So I'm left with cos square x minus sine square y, which is exactly what we expect on the right hand side. So to handle this problem, you need this identity of sine squared plus cos squared equal to 1. We also need a little bit of difference between two squares to do our expansion there faster, and that takes you straight to your answers. So guys, I hope I've actually helped you in compound angle identities. Thank you very much.